today on the bus structures of computer organization architecture. So we all know that computers will have central processing units, a memory units, as well as I/O units. All these units are based on hardware components or the modules of the computer, right? Now, all of these modules like a memory unit, processing unit, and I/O unit will work together with computing each other, and they have the paths for connecting the modules together. All right. In this process, all the collection of the information or all the collection of parts which is going to contain various modules. So all that is called as interconnection structure, which means one to one it has to get connected. Which three? Processing unit, memory unit, and I/O unit. So all of these three have to make some way to connect each other, right? There are many ways to connect in a different manner. It can be done by using single bus. It can be done by using multiple bus. That's what we're going to do it today. We're going to learn how these blocks are getting connected. There are many ways to get connected and different parts inside a computer together. Correct? So when we have a word of data, let us say I want to transfer one word of data from one place to other place. Correct? So if you want to transfer that, you can transfer the data either serially or you can transfer that in a parallelly. So these bits will be transferred simultaneously using many wires, or if you have a single wire, transmit one by one bit. So any option you can choose to transmit the data, right? So this kind of mechanism where a group of lines which will serve as the connecting path for several devices is called a bus, right? When we are trying to connect several devices, that is called as a bus. All right, and we have address, data, and control bus. Address bus we have, data bus we have, and control bus we have. Let us have a glance of these three, what they are. Buses. So this bus structure can be either a single bus structure or multiple bus structure. Let us focus on single bus structure. The main virtue of the single bus structure is what? Low cost model, which is costing very less, and it needs to be flexible in design. All right, and it should be attaching the peripheral devices. Whereas in case of multiple bus design, we achieve more concurrency in operations, and it also will allow us to uh, connect more number of devices, or we can able to say that two or more transfers can be obtained at same time. We can able to make that possible. Two or more at same point of time is possible in multiple bus structure. So because of that, we get a better performance, and the cost also will get increased in multiple bus structure. What about the speed issue? What about the speed issue in this? We are trying to use different kinds of devices which will use for different types of operating speed. What will happen, right? There are some kinds of devices which are electromagnetic in nature. Let us say like keyboard, printer. So they have a relatively lower speed. They cannot able to compute as fast as the normal computation is happening. All right, which is magnetic or optical discs are considered faster. The magnetic disc or the optical disc which we have are considerably faster than the other devices. And the memory involvement in the processor unit, which is going to be operate at the electronic speeds, are the fastest. Which I mean to say here is the memory and the processor unit, which will operate at electronic speed. They are faster. If you consider the speed as an issue, then we need to make sure that the slowest device connected to it has to work effectively. So if that is not working fine, then ultimately it affects the performance of the system. So how do we solve the speed issues? Because when I'm trying to connect one device to other, both of them may have a similar speed and same speed or may not have. So in this scenario, how do we solve this problem? By using buffer registers. One of the approach what we can do is we can have an adaptive approach of using a buffer register such that the buffer can store the data temporarily, and we can able to process the data based on the receiver speed. That is one option what we have here by usage of buffer registers. Second option is we can able to hold the data for some time when you are trying to transfer the data. We have a set of data with us, and if the receiver side data is not ready, nothing wrong in holding the data for some time. If you have that kind of mechanism, you can able to solve the speed issues. That is the second approach. First one is buffer usage, the second one is holding it, and the third option we have is smooth out timing differences among the processors. So let us say one device have one timing, the other one have a different timing. If we can able to figure it out and we can synchronize them, let us say like memories and IO devices, if we can synchronize them, we can also able to match the speed issues. So these are the three different approaches what we can use to match the speed issues. Along with that, we need to also have an look at system software. So what this system software is going to do, it will have the collection of all the programs what it is having, and all of them will be executed based on the functionalities. Let us say first one, receiving and interrupting user commands. So it will receive it and it will interrupt the user commands. Software has to receive it and it has to interrupt the user commands. And next is entering and editing application programs and storing them as files in secondary storage device. The system software has to make sure that the programs get edited and they get sorted in the secondary storage device. Along with it, it has to manage the storage, and it has to retrieve all the files in secondary storage device. The final point here is, so the standard application what we are using for the programs like the word processors or spreadsheets or games with data supplied by the user. So we need to make sure that they all function with the data what is being supplied by the user. If we continue this further, this software has to control the input block as well as the output blocks in order to receive the proper information in the output side. And while translating this programs from source domain by the user to the object, we want to consider the machine instructions. All right. So we need to link this when you are trying to use the written applications or the programs, and we need to make sure the use of standard library functions such that we can able to compute it in an effective manner with the help of numerical computational packages. Further, the system software is also having a responsibility in coordinating all its activities in the computing system. Let us say, for example, the applications which we use in programs are usually written in a higher level language, so it's like C, C++, Fortran, Java, and so on. So all of them are independent in nature, and the computer used to execute the program is again similar. So in this scenario, what the programmer has to do, the programmer has to use the higher level language, which he need to know all the details, and he need to know the machine programming instructions and all that. So for that purpose, we have something called as compiler, which will translate the higher level of programming into a suitable machine level programming. For that purpose, we have text editors. So usually the famous text editors are a notepad or an editor window. So any one of the place we can able to write the programs. Text editor or DOS prompt. So in this case, you can use any of them while editing the text. Similarly, the file what we have, it should be uh, have have a name appropriately, and it should have the binary data inside it, and it has to be stored in a secondary storage. And when we come to the operating system, it should be it should be a larger program, which is a collection of routines or subroutines, and it should be used in sharing and interacting the information among the users, which they're going to execute and run the appropriate programs. Let's take an example. We consider a system with one processor, one disk, and one printer. In this scenario, the program has to be compiled from higher level language into a machine level language, and it has to be stored on the disk. So this becomes a bit uh, right. See this one. The user has to run a subroutine to do that. In this case, you see this program is being shared here between the instance T1 and T2. The operating system will run a routine to the disk. The disk will allocate that to the operating system. The operating system routine will run the program between this time, and it gives back to the disk again. So disk again will acknowledge back to the program at this point of time. Further, we are able to print it. So in the example what we have seen here, we have one processor, one disk, and one printer. So one processor, one disk, one printer. This processor is going to access the program in a sequential manner based on the time deadline. Similarly, the disk also has been accessed in a time slot. Once we are able to complete this, we are ready to print the corresponding document and return back to the timeline. So this how the system performance will be based on, and let us see that performance of the system in the upcoming session. So thank you.